Right now, two spacecraft are orbiting Earth at over 17,000 miles per hour. Both are carrying astronauts home. Both are traveling through the same deadly debris field, but only one of them is coming back on schedule. China's Shenzhou-20 capsule sits stranded in orbit. Its three astronauts waiting as engineers on the ground run endless safety simulations. The culprit? A suspected collision with space debris, something so small you couldn't see it with your naked eye, yet powerful enough to potentially catastrophic damage at orbital speeds. Meanwhile, SpaceX's Crew Dragon has been navigating this same minefield for years without a scratch. Same orbit, same threats, completely different outcome. So what's the real difference here? Why is one spacecraft stuck while the other operates like clockwork? The answer isn't just about better luck. It's about a technology gap that's wider than most people realize, and it reveals something critical about the future of space travel. What SpaceX's president recently disclosed about Dragon's debris avoidance systems is eye-opening. And when you compare it to what happened with Shenzhou-20, the contrast becomes impossible to ignore. Welcome to Space Update 24 Hours, where we break down the stories that matter beyond the headlines. Today, we're taking you inside the invisible battlefield of low Earth orbit, where a storm of metal fragments traveling faster than bullets could determine who leads the next era of human spaceflight. Let's dive right in. On November 5th, three Chinese astronauts aboard Shenzhou-20 completed their 6-month mission on the Tiangong space station. They were scheduled to undock, fire their re-entry engines, and return to Earth within hours. But those hours turned into days, then weeks. The official word from China's space agency was brief but concerning. Possible debris strike, all descent operations suspended indefinitely. What followed was unprecedented. For a program known for its tight control over information, China did something remarkable. They went public. They confirmed the incident, acknowledged the delay, and revealed that engineers were running continuous simulations to assess the spacecraft's integrity. That level of transparency tells you everything about the severity of the situation. When a space agency that rarely discusses setbacks openly admits to a problem, you know it's serious. But here's what most people don't understand about space debris. The danger isn't just about size, it's about physics. In low Earth orbit, objects move at approximately 17,500 miles per hour. That's 8 kilometers every single second. At that velocity, a paint fleck carries the energy of a bowling ball drop from a skyscraper. A 1 millimeter metal fragment, that hits with more force than a gunshot. The Shenzhou-20 crew isn't dealing with a theoretical threat. They're sitting inside a spacecraft that may have already been compromised, waiting for confirmation that their heat shield, their hull integrity, their life support seals, all of it, can survive the violent friction of re-entry. And this isn't China's first encounter with orbital debris. In 2023, a piece of space junk punched through one of Tiangong's solar panels, causing a temporary power loss. Engineers responded by scheduling emergency spacewalks throughout 2024, installing additional shielding layers across the station's exterior. The Shenzhou-20 crew themselves participated in 4 of those spacewalks, reinforcing the very structure that's supposed to protect them. Now they're facing the same enemy again. Meanwhile, SpaceX's Crew Dragon operates in the exact same orbital environment, same altitude, same debris field, same risks. Yet in 2021, when a piece of debris came dangerously close to Crew Dragon during the Crew 2 mission, the response was completely different. NASA and SpaceX detected the threat hours in advance. Astronauts were instructed to seal themselves inside the capsule as a precaution. The debris passed harmlessly by. The mission continued without delay. So what's the difference? How does one spacecraft get stranded while another seemingly glides through the same minefield untouched? The answer comes down to 2 words: predictive avoidance. The United States operates the most sophisticated space surveillance network on the planet. Ground-based radars in locations spanning from California to the Marshall Islands continuously scan the sky. Telescopes in orbit track objects as small as a softball. The U.S. Space Force maintains a catalog of over 27,000 pieces of debris larger than 10 centimeters, and hundreds of thousands of smaller fragments that are monitored but not individually cataloged. Every piece of data flows into a centralized system that calculates orbital trajectories, predicts close approaches, and issues collision warnings, sometimes days in advance. NASA shares this information freely with SpaceX, international partners, and even commercial satellite operators. When Crew Dragon is in orbit, it's never flying blind. Its onboard systems receive constant updates about debris positions. If a potential collision is detected, even if the probability is just 1 in 10,000, the spacecraft can fire its maneuvering thrusters automatically, adjusting its orbit by mere meters to avoid the threat entirely. This isn't a reactive system, it's proactive. Dragon moves before the danger arrives. China's approach is fundamentally different. Their space surveillance network is smaller, more centralized, and designed primarily to protect Chinese assets. Domestic telescopes and a growing fleet of sensors provide coverage. But it's not global. It's not real-time in the same way. And critically, it's not integrated with international tracking networks due to both political restrictions and strategic concerns. Tiangong itself is equipped with debris detection instruments, but they can only identify objects larger than 10 centimeters. And only when they're already close, that's not enough time to maneuver. That's barely enough time to brace for impact. Instead of dodging debris, China's strategy has focused on building tougher spacecraft, reinforced hulls, layered shielding, redundant systems. It's a defensive posture, like wearing armor instead of learning to sidestep the punch. And here's where the gap becomes stark. SpaceX's Starlink constellation, over 6,000 satellites, performs autonomous collision avoidance maneuvers thousands of times per year. Each satellite receives debris tracking data, calculates risk, and adjusts its orbit without human intervention. It's a fully automated system operating at a scale China hasn't yet achieved. The cost of this disparity is measured in more than just technology. A single debris removal mission, using robotic arms, nets, or propulsion systems to capture and deorbit a piece of junk, costs between $100 million and $500 million. Laser-based systems that could nudge debris out of dangerous orbits. NASA estimates those could run upwards of $1 billion per installation. China is investing in active debris removal research, but these technologies are still experimental, still years away from operational deployment. There's another factor complicating China's efforts: secrecy. Much of the technology used to track and maneuver around debris could also be used to track and target satellites. In a geopolitical environment where space capabilities have direct military applications, sharing data becomes a strategic risk. The United States faces similar concerns, which is why the Wolf Amendment prohibits NASA from collaborating directly with China on most space projects without congressional approval. The intent is to prevent technology transfer that could enhance China's military capabilities. But this separation has created two parallel space infrastructures evolving independently. One built on international collaboration and shared data, the other on self-reliance in controlled information. And when debris strikes, those differences matter. The Shenzhou-20 incident immediately ignited debate online, and not all of it was sympathetic. Some observers pointed out the historical irony. In 2007, China conducted an anti-satellite missile test that deliberately destroyed one of its own weather satellites. That single event created over 3,000 trackable pieces of debris, many of which remain in orbit today. The question being asked now is uncomfortable but unavoidable. Is China now facing the consequences of its own actions? Others see this as a potential turning point. When a nation becomes the victim of a problem it helped create, the motivation to solve that problem intensifies. Some hope this incident will push China toward greater transparency, more international cooperation, and serious investment in debris mitigation. But skeptics remain. Statistically, China is one of the largest contributors to space debris, second only to Russia. And while accidental collisions do happen, there's also a more cynical perspective circulating. What if the debris strike narrative is just a convenient cover story for a different kind of failure? One that's harder to explain? Orbital debris is unpredictable and nearly impossible to verify from the ground. It's the perfect excuse for technical malfunctions, system errors, or design flaws that might otherwise be embarrassing to admit. There's precedent for this suspicion. In past incidents involving damage to spacecraft, initial reports attributed the cause to debris impacts, only for later analysis to reveal other factors. The truth is, unless you can recover the spacecraft and examine it physically, You're relying on telemetry data and simulations, both of which can be interpreted in multiple ways. Whether this is truly a debris strike or something else, the incident has exposed a broader issue. Media coverage. Major Western outlets largely ignored Tiangong's existence until something went wrong. A November analysis showed the South China Morning Post published dozens of articles about the station, while leading U.S. newspapers ran just a handful British and Australian papers. Almost nothing. Space, it turns out, is viewed through the same geopolitical lens as everything else. But beyond the blame and the politics, the real question is, what happens next? 3 solutions are gaining traction. First, technological standardization, specifically universal docking systems that would allow spacecraft from any nation to assist each other in emergencies. This already exists in the form of the International Docking System Standard, or IDSS, which both the ISS and Tiangong have adopted. In theory, a SpaceX Dragon could dock with Tiangong if necessary. Second, enforceable international regulations that mandate debris mitigation. Every nation launching satellites should be required to deorbit them at end of life or move them to graveyard orbits. SpaceX already does this. Crew Dragon is designed to return to Earth intact, and Starlink satellites deorbit automatically when they reach the end of their operational life. Third, and most ambitious, active debris removal. Someone has to start cleaning up the mess. SpaceX has explored using Starship to capture debris with nets, harpoons, or even directed energy systems. China is researching robotic capture mechanisms. But these are expensive, complex, and politically sensitive missions. The truth is, low Earth orbit is becoming a junkyard. Every rocket stage left behind, every satellite collision, every weapons test adds to the problem. And as more nations and private companies launch satellites, the risk of cascading collisions, where one impact creates debris that causes more impacts, grows exponentially. Right now, those 3 Chinese astronauts are still waiting. Engineers are still running simulations, and the clock keeps ticking. The Shenzhou-20 incident isn't just about one spacecraft or one debris strike. It's a preview of what's coming. As more satellites fill our skies, SpaceX alone plans to launch 42,000 Starlink satellites over the next decade. The orbital environment will only get more crowded, more dangerous, more unpredictable. The technology gap we've seen here matters because it determines who can operate safely in that future and who can't. SpaceX's predictive avoidance systems, their automated maneuvering, their real-time tracking integration, these aren't just competitive advantages. They're survival tools. China is catching up, investing billions in space infrastructure and debris monitoring. But catching up takes time, and in orbit, time is measured in split seconds. One collision at 17,500 miles per hour can end a mission, destroy a spacecraft, or worse. What this incident really reveals is that space isn't infinite anymore. It's not the vast empty frontier we once thought it was. It's a shared environment with limited safe routes, growing traffic, and consequences that affect everyone, regardless of which flag is on the rocket. The question isn't whether China or America has better technology. The real question is whether we'll cooperate to solve this problem together or let national competition turn Earth's orbit into an unusable debris field that locks humanity on this planet for generations. So here's what I want to know from you. Do you think the Shenzhou-20 debris strike is real, or could it be covering up something else? And more importantly, do you believe international cooperation in space is even possible given the current geopolitical climate? Drop your thoughts in the comments below. I read every single one, and some of the best discussions happened down there. If this breakdown gave you a new perspective on what's really happening above our heads, hit that like button. Share this with anyone who thinks space exploration is just about discovery. It's also about survival. And if you want to stay ahead of the stories that mainstream media misses or ignores, subscribe to Space Update 24 hours and turn on notifications. Because the next chapter of this story is already being written in orbit, and you'll want to know how it ends. Thanks for watching. Stay curious, and remember, the sky isn't the limit anymore. It's just the beginning.